In this last video of this section, we will introduce some properties that will help us when computing limits. The properties that we will study are the following. So throughout these properties, k will be a constant number. The limit of a function f when x goes to a will be equal to L, and the limit of a function g when x goes to a will be equal to m. So the properties are the following. The first one is that the limit of a constant function when x goes to a is equal to the same constant. The second one says that the limit of the function x when x goes to a is equal to a. The third one, it's a combination of two properties, which says that the limit of the sum of two functions will be equal to the sum of the two limits. And the same goes for the difference of two functions. So the limit of the difference of two functions will be the difference of the limit. That's why we use this plus minus sign at the same time. The fourth property will be that the limit of the product of two functions will be the product of the limits. The fifth property that we will study is that the limit of a quotient of function is equal to the quotient of the limits, with the only condition that m, the limit on the denominator, has to be different than 0. Because remember, we cannot divide by 0. The last property we will study is that the limit of the nth root of a function will be equal to the nth root of the limit, with a similar condition as above, that the limit L has to be positive when n is even. For example, we cannot find the square root of a negative number. So to prevent that problem, we require this condition. So let's use these properties to actually compute some limits. So let's do the first one. The limit of the function x cubed plus 3x minus 2 when x goes to 2. So first of all, we can use property number 3 that allows us to separate sums. Now we have to compute these three limits separately. So the first one, well, x cubed is the product of x times x times x. You multiply x 3 times. So let's write that down. The second limit, well, this is also a product of 3 times x. So we can use property in fact number 4 to separate it. Finally, we have the limit of a constant. So that is property number 1 that tells us that that limit is in fact equal to 2. So this last part is over. So for the first limit now, we have a product. We have to use property number 4 now 2 times because we have two products. But eventually we will get that it is the limit of x times the limit of x times the limit of x. And we have that the limit of x when x goes to 2 is equal to 2. So we will get in this case 2 times 2 times 2. Finally, the second limit we have to compute is the limit of a constant, which will be equal to 3, times the limit of x, which will be equal to 2. That minus 2 that we already computed before. If we do the math here, we will get that this is in fact 12. For the second one, pause the video and try it on your own, and then we will do it all together. Great. So to start this limit, we have to use property number 5, which is the quotient, the limit of a quotient. So in this case, this will be equal to the limit when x goes to 4 of x squared minus 2x divided by the limit when x goes to 4 of x minus 1. Okay? So now we can repeat the same computation as we did before, and we will get that this is equal to the limit when x goes to 4 of x squared minus the limit when x goes to 4 of 2x divided by the limit when x goes to 4 of x minus the limit when x goes to 4 of 1. Here notice that we used property number 3. So finally we can compute these limits as before, and we will get that this is 4 squared minus 2 times 4 divided by 4 minus 1, and this is 8/3. The last result we will use to compute limit is the following. So if we have two functions that are equal when x is not equal to a, then the limit of these two functions are the same, provided that the limit actually exists. So this result encodes what we did in the first video. So let's see this with another function. So we want to calculate the limit when x goes to 3 of the function x squared minus 3x over x minus 3. To do so, let's start by seeing what happens with this function when x is equal to 3. So we can try to evaluate this function, and we will get the following: 3 squared, which is 9, minus 3 times 3, which is 9 again, divided by 3 minus 3. So this will give us something like 0 divided by 0. So we put quotations mark here because we cannot actually evaluate the function at 3 because it's not on the domain. What we can do is notice that if x is not equal to 3, then first of all we can factor the expression on the top of the fraction. So we can rewrite this as x times x minus 3 divided by x minus 3. So now, because x is not equal to 3, then x minus 3 is no longer 0. So we can simplify these expressions. And we get that our function is in fact equal to x when x is not equal to 3. So the theorem above let us says that the limit when x goes to 3 of x squared minus 3x divided x minus 3 is in fact equal to the limit when x goes to 3 of x. And now we can use property number 2 to actually compute this limit, which is equal to 3.